What is up, everyone? Let's continue with Blocker, right? So, a couple stuff you need to do. Let me open up real quick chain, right? And we are already here, actually. That's where we left off, right? We basically are storing our UTXOs, and we're storing them by basically, let me quickly see, we make an address, right? And then we basically do this and store the hash of the transaction, right? That's how we basically do that. I want to change this up. Because this is going to be so hard to fetch them later on. So what we're going to do is we're going to change that by doing a hash of the transaction. And then we're going to basically do the output. The output of the previous transaction. Yeah, that's... Wait, I mean, let me quickly... No. The hash of the transaction and the output in that transaction. That's what we, in the input. Output. I'm so sorry. So, because basically, we can have multiples, right? And if we, so we're going to have these outputs right here, right? And what we're going to do then is basically fetch the transaction first. Then we're going to check how many, the length of the outputs probably, right? And then we're going to have a number, and then we can actually iterate over the hash and fetch them all, right? If that makes sense, So, and able to do this, we're gonna make a key, which is going to be a hash and a percentage. I don't think we need the address here. So we're going to say it's going to be the hash of the transaction in a combination with the it, I guess, right? Because we are ranging over the outputs. It is so weird, right? I'm using it because it stands for iterator, right? But hey. So we're going to have a key here. Then we're going to store. We don't want to... Let me open up this storage real quick because I don't think we need this. If you want to put it, we can do a put with UTXO itself. Because, memory UTXO store, because we can do this, we're gonna lock it, right? Then we're gonna say that the key is going to be fmt sprint f percentage s underscore percentage d. And what we could do is we're gonna say it's gonna be the UTXO hash and the UTXO out index, right? That's the key. That's fine. So that basically means we only need the UTXO here. We don't need to make the key here. That's actually better. Address TX hash, that's not true. We're gonna delete that. It's gonna be, it doesn't actually matter here. I think you're gonna have some problems with tests. Make test. Fail, that's true. I think it's gonna be a chain test maybe. Here, right? So check if there is a UTXO that is unspent. So check if let's do the check like I mentioned. Check if all outputs are unspent by querying the UTXO storage. Just like that. So we don't need the address actually. First of all, we're gonna say that the TX. Let's first grab the TX, right? So we're gonna first grab the TX. That's going to be TX store get. How do we? Probably on a hash, right? It's gonna be the TX hash, right? We're gonna get that. We're gonna actually assert nil t r. Then we have a TX, right? We already have a TX here. So it's gonna be fetch TX actually. Fetch TX. Right, because we already have a TX and it's gonna be the same. So we have a name collision. So we're gonna we're gonna say the fetch TX. In a test, I most of the time do that because we're gonna create a transaction, then we're gonna fetch it back from the storage. So we give that also, we need to give that TX a name, and TX has already been taken, so I'm gonna call this fetch TX. It's the TX we fetched from storage. Man, I hope I'm not getting sick once again. It's crazy, man. The world is fucking. It's crazy, right? So we have fetch TX here. That's fine. Then what we could do is we could do something like outputs len output actually and outputs is going to be the length of the fetch TX outputs, right? And then what you could do is for and outputs. What's going on here? And outputs, right? Then we're gonna basically grab the UTXO. It's gonna be, let's make a key here, right? The key is going to be, I don't know, for now we're gonna make this X, so we don't have a compiler error. It's gonna be chain UTXO store get, right? The key. We're gonna assert nil t r, right? That's what we're gonna do. Actually, this we don't need that. Then we have a UTXO, and we're gonna say UT assert equal t. Actually, assert true is gonna be fine. UTXO spent is false. Right. Of course. Now we need to fix the key. The key is going to be fmt s print f. And it's going to be %s underscore %d. And we know it's going to be the tx hash actually, right? And we want the iterator, right? Let's try. No, not make run. It's gonna be make test actually. It's failing, right? Why? What's going on here? Actually, there's too much going on. Let's. Damn, this is such a big test. Boom. Should be true. Okay, cool. No. I see what's going on here. We make a mistake here. It's not going to be assert true. It's going to be assert false, right? What are we doing here? Why can we actually put multiple things here? Assert false spent. That's what we want. Boom. And everything is working fine, right? So that's how we check. That's fine. That's cool. So that basically means that we can we can open up chain actually. What is this? Validate block. Verify the transaction. I'm gonna make a new function actually. Validate transaction. Types, it's not types, it's gonna be proto actually. Proto transaction, right? As we're gonna do, we're gonna maybe return an error, right? And we're gonna say here, yeah, we wanna validate the block, verify the block, get all that stuff. And then we have transactions. What we could do is this, right? We're gonna verify the transaction here, and then we're gonna say if C validates transaction dx. If there is an error is not null here, we're gonna return the error. Just like that, right? So we're gonna verify this transaction, and then we're gonna basically check that all this stuff needs to be unspent, right? So what we could do is actually open up this test, to be honest, and we can copy some stuff, right? Verify the signature, right? And then we're gonna say check if all outputs are unspent, something like that. So we're gonna be something like this, right? So it's gonna be dx, right? Dx. The hash is gonna be types hash transaction dx. Then we're gonna have a chain. That's gonna be C. So then we're gonna have an error here. If R is not null, we're gonna return the error. Then we have in UTXO, if UTXO spent fmt error f output of tx is already spent. It's gonna be output is gonna be y. Damn. We're gonna take this. Actually, gonna make hash here. So the output of this transaction hash has already been spent. Yes. That's that. What's going on here? There's a key, yada yada, that's fine. Then we're gonna actually return null here, okay. Shit, we are failing for some reason. Could not find UTXO with hash. That's a problem in our test, actually. Validate transaction. Are we actually... how is this possible? It's gonna be here in this test here. We're adding the block. It's this test actually. It's the big test. Yeah, I think it's gonna be a problem because we have could not find UTXO with hash. I think this needs to be a hex. Decode. Encode the string, is it? I think we need to do that, to be honest. Damn. Damn. What are we doing here? I see what's going on. I see what's going on. Damn. The problem is we need to check the inputs, right? We need to check the inputs of the previous transaction. Damn it. We are checking already our own outputs, which basically are always out. Yeah, I see. That's a problem. Wait. Let me quickly see what I need to do, because it's getting complicated, I'm gonna lie. So we have this, yeah, the inputs are basically the output from a previous transaction. That's what we need to do. We need to check these inputs instead of this stuff. Check if all the inputs are unspent, right? So we need to check the inputs. It's my bad. So we're gonna basically get, based on the hash. That's not true. It's gonna be based on the... takes inputs y. Pref takes hash. That's what we're searching for, right? Because this input is basically an output at this hash. That's what it is. Actually, I should make this test a little bit better, to be honest. The previous test, because this is going to be a problem. This is not going to work. Damn, how can we... Let's open up chain test a little bit, because we make a mistake here. Let me close these things, because they're distracting me for now. All right, so this is basically... This is basically the pref TX, right? Previous TX. Pref TX, that's this. That's fine. So what we do is we use that transaction, we query that transaction so we can use... yeah, because we can use an input. And this is going to be the output of the previous transaction. Because this is basically the genesis, right? Guys, I know it's gonna be so complicated. I understand, but it is what it is, guys. I cannot. You know that I'm the master of simplicity, but this is it's another beast. That's why you cannot find this on the internet. That's why nobody has a clue what's going on, because this is very, very... It's not hard, but it's just... It's hard to get your logical connections around it. It's hard to keep your dopamine flowing in these things. I understand. But we need to get through this part, because otherwise we are not making a blockchain, right? We are making garbage. And we don't want that, right? Because then we are just like all the other tubers. You know what I mean? So let's recap. Right. So if I want to make a new transaction, right? That basically means that I need to provide two things in that transaction, right? I need to provide an input or multiple inputs, which basically is going to be outputs of previous transactions sent to me. Right? an output of a transaction is always going to be an input of the next transaction for myself, right? So if I want to send 100 coins to you, I need to provide, so that's going to be an output. I'm going to make an output, 100 tokens to your address. That's an output in my transaction. But I need to have an input with, or multiple inputs with the sum of at least 100 tokens. If that makes sense. So, of course, because we have an application that basically is going to be boot up from the ground, right? There will be no transactions yet. So, in able to test this, what I need to do is I create this Genesis block, right? And the Genesis block is basically the first block of the blockchain, right? And what I'm going to do is I'm going to basically create some coins out of thin air, these 1,000 coins, and I'm going to send them. I'm going to send these 1,000 coins to this private key. And this private key is basically going to be the God seed. So it's going to be the address of the God seed. And that's going to be here, right? So what we're going to do is we run this transaction, we got the hash of the transaction here, and we're going to fetch that transaction so we can use the output as an input for our test, if that makes sense. I hope this makes sense. It's so complicated, and that's why it's so important to understand this. That's why it's also so super secure, and that's why it's also, yeah, it's good. But it's complicated, and probably we're gonna make some mistakes here and there, but it is what it is. Sometimes it's gonna be. You cannot do something without making mistakes. It's impossible. I hope this is clear. All right, I hope this is clear. So we have this priv3x, and we're gonna use the first. Let's open up this Genesis once again. It's gonna be in chain probably. So if you see this Genesis, we have no inputs because we are creating it from thin air, but you have this output, right? And the first output, right? This is going to be index 0, right? Index 0, output 0. That's going to be this 1,000 stuff, right? And that's exactly what we do here, right? This transaction, this input, priv out index 0 is going to be this guy here with the amount of 1,000, right? Then we create two outputs, right? Because we have an input of 1,000. So we need to send, if you want to send 100 coins, I'm going to make an output with 100 coins to you. And then I'm going to make an output with 900 coins back to me. All right. So we're going to do this stuff. We're going to append it to a block and yada, 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 yada. So what's going to happen is validate transaction, right? I'm going to check. There's one, and there is only one output, right? So I'm going to check the priv3x. I'm going to get that key. That should be stored. Okay, cool. So I think we can test this. I think we can. You're failing, right? Could not find UTXO with this stupid hash. I think we make a problem. Ay, 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 ay. It's gonna be string or bytes. Yeah, I see what's going on. The problem is with this Genesis block. Yeah, so we create this Genesis block here, right? Oh, we do store everything, that's fine. That's the hash. Put UTXO. And we store the transaction here. Alright, so let's open up store. Once again, I'm so sorry. It's the UTXO with this hash. That's the problem here. Yeah. It's going to be this error. Let me see what's going on here. Println is going to be tx inputs 0, y actually, pref tx hash. It's going to be the p hash, like this. Let's see what's going on here. These are bytes, right? So that's the thing. Oh man. So we're going to X encode to string, probably this, right? We're going to say tx inputs y pref tx hash. That's going to be it. And then instead of doing this, it's going to be the pref hash, and that should be fine. Pref hash. That's fine. P hash, right? All right. Let's make it a little bit cleaner, maybe. Actually, it's fine. So basically, it's already spent. That's fine. Wait, so it's going to be input of tx is already spent, right? That's inputs, right? Check if all the inputs are spent. Cool. Right. So let's open up chain test real quick. Chain test. Boom. Check if all... This is actually a wrong test, right? Because... we don't need to test this because we're already testing this, right? And it's also wrong. We're going to fetch the txt, that's fine. We actually don't need this. txs, we don't need this, right? The only thing we want to require is that we add block, that's fine. Another thing actually is what we should test is basically that we can, for example, in this case, this is a good case. So we're gonna actually make a new test. Let's call this func test. Damn. We're actually doing a big test, right? So I mean by that is that we're not unit testing this. We're actually already testing adding a block with a transaction, because I think it's it's fine. So test add block with tx insufficient funds. How can we say that? Low funds or something. I don't know. You tell me. So we're gonna say testing t, right? So So basically, we're gonna copy this whole shebang. So we can actually, we're gonna make inputs, outputs, transaction. We're gonna do the whole bang. We're gonna copy the whole transaction. The whole test, I mean. And then what we're gonna do is instead, so we're gonna take these 1,000 coins we have from our Genesis, but instead, what we're gonna do, I'm gonna basically make one output here, and I'm gonna send 1,001, which cannot be, right? We cannot do that because we don't have enough. Okay, so these are the outputs, right? So I'm creating an output, which is basically needs to be verified from the input. So we need to, this is basically going to run perfectly fine. Look at this. So this is running perfectly fine. It's going to be cached for some reason. But that cannot be, right? Test add block with the UTXO funds, insufficient funds actually. How do we write this? Insufficient funds, something like that. Right, how are we gonna test that? Well, basically, if we go to, how are we gonna fix that? So first of all, we're gonna check if this is all unspent, that's true. And then what we need to do basically is sum in. Actually, what I'm gonna do is for underscore input range it's a lot of code, right, guys? It's crazy. I know it's not like the account model. The account model is super simple because you can just, it's all stored in a database and you can just fetch, based on an address, you can fetch the current account balance, right? And then if you need to, that's how you verify. But it also comes with insecurities. But anyway, so we're going to have this input. So what we're going to do is, damn, how do we check this? Damn, so an input is basically an output from the previous transaction, right? So we're gonna say wait, are we doing this already here? I think so. Wait, let me delete this. It's gonna be the right, these are the sum inputs, right? So this is the pref hash. We're gonna check the UTXO. Actually, maybe we can check it based on UTXOs, actually. Is that a thing? So if the sum inputs is smaller, wait, now we need to have some outs actually. If wait, we're gonna do like this. We're gonna say for underscore output in range tx outputs. We're gonna say that the sum outputs plus equals is going to be output amount, right? That's it. So we're gonna say if the sum of the inputs is smaller than the sum of the outputs, we're gonna say return fmt println insufficient balance. Boom. It's not gonna be println, it's gonna be error f, right? Insufficient balance. Maybe we're gonna do something like God have want or need. Got this. Wait, spending this. Some inputs, some outputs. Something like that. Whew! Alright, so we're failing. Alright, okay, cool. Yes! Yes! I think it's working. So, insufficient balance got 1000, but we are spending 1001. That's exactly what... Oh, this is so complicated, but hey, it's working, and that's good. So this is a chain test, right? So, you can see, basically... Let's delete this shenanigans. That we... Here. And then we assume everything is going to work in this test, but that's not true. So we need to require, right? We need to require here, instead of null, we need to require not null, right? Not null. Because... because adding a block should fail, because we don't have enough balance, right? Yes, so now it's working all fine. Look at this, guys. Look at this. Perfectly fine. Now we have some very good validation, right? Very good validation with UTXOs. We are getting a UTXO expert. It's complex, but hey, very important stuff you need to understand, right? So I would consider the last 2 episodes, or maybe last 3, I think last 2 episodes, that you have a very good grasp on how the UTXOs are working. It's super, super, super important. It's so important, right? Of course, I think the UTXO model is something that's not going to be used often anymore in blockchain, but don't forget that Bitcoin is using a UTXO model, and it will always be using a UTXO model. And Bitcoin is also, in my opinion, the only cryptocurrency that matters, right? Crypto, it's the only true decentralized cryptocurrency, and it's the basics, it's the base, you need to understand that. And UTXO is a big part of it. All right. So I think in the next episode, we're going to do the Merkle root of the transactions. Very important. The Merkle root, the Merkle tree actually. And then we're going to create a Merkle root and put that in. It's basically, let me open up Proto real quick. So we're going to put that here. The root hash basically is the Merkle root of the X. We don't do that. It's very important. So nobody can tamper with our transactions. It's another validation we need to do. And I think after the Merkle root, we have all validations we need. So nobody can fuck up our system. Right? All right. I see you in the next episode. Peace.